You know you're standing in a sports bar, right? And you're staring at this massive 16 by 16 wall of TVs acting as one giant, perfectly synced screen.
Yeah, and a decade ago, running that meant miles of expensive, heavy cables,
Which will-
plus an engineering degree just to turn it on.
Exactly. But today, it's all being done invisibly over the exact same network cables that run your office internet. So our mission in this deep dive is to decode the magic of commercial AV networks. We're looking at a spec sheet from HDTV Supply for an Avenview HDMI over IP system. Okay, let's unpack this. Think of traditional HDMI like a massive continuous water pipe.
Right, a huge physical pipe.
Yeah, but HDMI over IP is entirely different. It's like chopping that water up into millions of tiny numbered water balloons, shipping them down a multi-lane highway, and bursting them all at the exact same time at the destination.
That water balloon analogy gets right at the heart of packet switching. Historically, video signals required a dedicated, continuous physical connection directly from the source to the screen. You were just completely bound by physical distance.
Right.
But shifting to IP, or Internet Protocol, means you're turning video into standard network data. You route it through the same local area network switches that handle, emails or regular web traffic.
Wait, if everything is running on standard network switches, doesn't that mean you aren't limited by physical cables anymore? Like you could have the video source in a basement server room and the screen's way up on the 10th floor.
Exactly. That's the primary advantage of treating video like data. And to pull that off, the Avenview system uses two main pieces of hardware. There's an encoder to package the video at the source and decoders at every TV to unpackage it.
Okay, got it.
But uncompressed high-definition video is a massive fire hose of data. To fit that down, a standard CAT5E or CET6 network cable up to 330 feet away, the encoder uses H.264 compression. So instead of sending every single pixel 60 times a second for a 1080p signal, it only sends the pixels that actually change from frame to frame. It drastically shrinks the data footprint.
And because they can use a power over Ethernet network switch, like say a Dell Networking 5500 series, that single network cable delivers the video data and the electricity to power the decoder. No messy power strips hidden behind the TVs, which is amazing.
Yeah, it cleans up the install so much.
But turning video into network data creates a new problem, right? And network traffic isn't always perfectly smooth. If we're compressing high-def video and sending it over a shared network, doesn't that cause a delay? Like if you're watching live sports, a delay is an absolute deal breaker.
Oh, definitely. And what's fascinating here is how this system handles that exact bottleneck.
Yeah.
Through adjustable latency. You actually get to define the priority.
Really? How so?
Well, if you're showing a live game, you select low latency mode.
Yeah.
It compresses the video faster, dropping the delay to between 60 and 90 milliseconds, which is virtually imperceptible to the human eye.
Wow.
But if you're showing, say, high-end digital art, where visual perfection matters way more than real-time speed, you switch to high-quality mode. That gives the system 250 to 300 milliseconds to process a much cleaner, richer image.
So you balance speed and visual fidelity based on the actual need. But once that data is traveling on the network, how do you keep 16 separate screens from falling out of sync when they're all fighting for bandwidth? I mean, I'm picturing a giant engineering board with hundreds of knobs.
Oh, you don't need the engineering board at all because the decoders handle the syncing locally. They have built-in auto-scaling and rotation. Plus, they feature something called seamless switching.
What does that mean, practically?
So in older setups, whenever you changed a video feed, the TVs would flash this jarring black screen. That was the TVs performing a digital handshake, basically trying to sync up the new resolution and frame rate.
Ugh, yeah, I hate that.
Right, but seamless switching actively holds the current frame on screen while that background handshake happens. It eliminates the blackout entirely.
Here's where it gets really interesting. Because the system is just managing network data, you can literally preview and route all your video feeds to any screen on the wall using a standard Windows PC. Or just an iPad app.
Yeah, and if we connect this to the bigger picture, features like zero configuration networking are completely democratizing high-end audiovisual setups. We are taking incredibly complex video engineering and turning it into an intuitive drag-and-drop user experience.
So what does this all mean? I mean, the fact that you can run a venue's entire visual infrastructure for under $1,000 using off-the-shelf IT equipment completely changes how you view commercial spaces.
It really does shift the whole paradigm.
Exactly. Understanding that a system like this Avenview setup costs $998, complete with a current 10% discount and a 3-year warranty, proves this once exclusive tech is now accessible to almost any business.
It really is. And this raises an important question for you to think about. If standard internet protocols can perfectly synchronize a massive 16 by 16 wall of live HD video with millisecond precision, what other physical infrastructures in our daily lives are quietly being replaced by invisible networks?